Bismillah ar-Rahman ar-Rahim. My dear student, today we will take the final revision on Geometry Prep 3, second term. First, we must remember the definitions and the basic information in the second term. As you see here in the first picture, if you have the circle M and MC is a straight line, passes through the center of the circle M and bisect the chord AB. Therefore, MC straight line perpendicular to the line segment AB. Second, if MC passes through the center M and we have a chord AB and MC straight line is perpendicular to the chord AB, what do you deduce? Yes, we deduce that the straight line MC bisects the line segment or the chord AB. So here BC will equal to CA. Third, if you have the circle M and we have the central angle AMB equal 90 degree, so BM and AM are two radii and perpendicular to each other, and we have the chord AB equal 10 centimeter. Therefore, measure of the angle A equal measure of the angle B. Measure of the angle A equal measure of the angle B. Why? Because the triangle AMB is an isosceles triangle, because MA and MB are two radii in the circle. Yes, so the two base angles of this isosceles triangle are equal in measure. So measure of the angle A equal measure of the angle B. In this picture, the straight line L is a tangent. What the meaning of the tangent? Remember, the tangent is a straight line or a line segment or a ray touches the circle at one point. As you see here, the straight line L touches the circle M at the point A. So the straight line L is a tangent of the circle. And MA is a radius here. What do you deduce? Yes, MA, the radius, is perpendicular to the tangent L. Or vice versa, the tangent is perpendicular to the radius. The next, if we have two tangents of the circle, the straight line L and the straight line K are two tangents of the circle M, where, yes, at the end points of the diameter AB. You see here, AB is the diameter because it passes through the center M. The end points of the diameter are the 2 points A and B. The straight line L touches the circle at A, and the straight line K touches the circle at B. What do you deduce? The two tangents L and K are parallel. Why? Yes, very good. Because L is perpendicular to the diameter at A and the K perpendicular to the diameter at B. Measure of the angle LAM equal 90 and the measure of the angle KBM equal 90. So the two straight lines L and K are parallel. So we have two tangents at the endpoints of the diameter AB. What do you deduce? The two diameter at the end points of the two tangents of at the end points of the diameter are parallel. The next, if we have two chords AB and DC are equal in length, and MX perpendicular to the chord AB, and also MY is perpendicular to the chord DC, what do you deduce? Very good, we deduce that MX is equal to MY. MX equal to MY. And vice versa. If MX is equal to MY, therefore AB, the chord AB, equal the chord CD. The next, if we have two chords here, AB equal DC, then the measure of the arc AB, equal measure of the arc CD, and vice versa. What's the meaning of vice versa? If the chord, the measure of the chord AB equal the measure of the chord CD, therefore the measure of the arc AB equal the measure of the arc CD, therefore the measure of the chord AB equal the measure of the chord CD. Now, if you have two parallel chords, AB is parallel to CD in this circle, the circle M, what do you deduce? Very good. The measure of the arcs between them are equal. So, measure of the arc AC equal measure of the arc BD. And also you can deduce that the length of the arc AC equal the length of the arc BD. The next, if you have a circle and you have a tangent like CD, it's parallel to a chord AB, what do you deduce here? Yes, very good. The measure of the arc EC equal the measure of the arc EB. And also you can deduce that the length of the arc EA equal the length of the arc EB. Remember here the central angle and the inscribed angle. First, what is the central angle? The central angle, it is an angle inside the circle. Its vertex is the center of the circle, and the two sides are two radii of the circle. The measure of the angle AMB, this is the central angle, equal twice the measure of the inscribed angle. What is the inscribed angle? The inscribed angle, like see here, its vertex lies on the circle, and the two sides of it, CB and CA, are two chords of the circle. And the vice versa, you can say measure of the angle C equal half measure of the angle M, or the measure of the inscribed angle equal half the measure of the central angle subtended by the same arc. The same arc here is the arc BA. As you see here, measure of the inscribed angle C equal half measure of the central angle. So, measure of the angle C here equal half the measure of the arc AB. And what also? Also the measure of the central angle M equal the measure of the arc BA. Now we have a diameter in the circle M. What is the diameter here? The diameter is AB because it passes through the center. and the inscribed angle ACB drawn in a semicircle. So the measure of the inscribed angle drawn in a semicircle equal 90 degree. So if we have a diameter AB, therefore the measure of the angle ACB equal 90 degrees. Now we have a well-known problem. What is the well-known problem here? If you have two chords intersect at the point E. Now we have the chord AB and the chord CD intersect at the point E. You can get the measure of the angle AEC as the following. Equal what? Equal half times measure of the arc AC plus measure of the arc BD. The well-known problem 2, if you have two rays from a point outside the circle, the point outside the circle here is A, and the two rays AC and AE, and the first intersected the circle at the 2 points B and C, and the second intersects the circle at the 2 points D and E. You can find here measure of the angle A by what? Yes, equal half times measure of the arc CE. Yes, very good. Here is minus measure of the arc BD. If you have two intersecting circles here, M and N, intersect the 2 points A and B. What is the name of MN? MN is called the line of centers. The line of centers. And the AB is called what? Yes, it is a common chord between the two circles M and M. So the line of centers MN is perpendicular to the common chord and bisect it. So you notice that MN perpendicular to AB and bisect it. Now we have more than one inscribed angle subtended by the same arc. You have angle AEB and angle ADB and angle ACB. All these inscribed angle have a common chord AB. What do you deduce? Very good. Measure of the angle B, measure of the angle E, measure of the angle E equal measure of the angle D equal measure of the angle C, subtended by the same arc AB. Now we'll take the cyclic quad. What is the cyclic quad firstly? The cyclic quad, it is a quadrilateral, yes, has 4 sides and 4 vertices. All of these 4 vertices lies on the same circle. So the cyclic quadrilateral, its vertices are lying on a circle. First case, if you have a common base, what is the common base here? The common base is the line segment BC, and you have angle BAC named by angle 1 and angle BDC named by angle 2. What is the relation between two angles? Yes, they are equal in measure. Since measure of the angle 1 equal measure of the angle 2 and drawn on the same base BC and also on one side of the common base, so ABCD is a cyclic quad and vice versa. The second case, each two opposite angles of the cyclic quadrilateral are supplementary. So measure of the angle A plus measure of the angle C equal 180. Also measure of the angle B plus measure of the angle D equal 180. If you find two opposite angles of a quadrilateral are supplementary, so the quad is a cyclic, and vice versa. Third case, if you have an exterior angle at a point equal to opposite to the adjacent angle at this vertex, so the quad is a cyclic. Look at this figure. The measure of the angle CBE, the exterior, equal measure of the angle D, yes, the interior, opposite to the adjacent of the exterior. So ABCD is a cyclic quadrilateral and vice versa. If you have two tangent segments like AB and AC, two tangent segment, therefore the length of AB equal the length of AC. If you join MB as a radius and MC another radius, what do you deduce? Yes, MBA equal 90 degree, MCA equal 90 degree. Also, AM, this line segment joining between the point A and the center M, is perpendicular to BC and also bisect it. So BE equal CE. And we can deduce that ABMC is a cyclic quadrilateral because measure of the angle B plus measure of the angle C equal 90. Two opposite angles are supplementary, so ABMC is a cyclic quadrilateral. Now you have a tangent of this circle at the point A, and this is a chord, and D is an inscribed angle. What do you deduce if AC is a tangent? Therefore, measure of angle of tangency BAC equal the measure of the inscribed angle D subtended by the same arc AB, same arc AB. And also you can deduce that the measure of angle of tangency BAC, this angle, equal half measure of the central angle BMA, because this is angle of tangency, equal half the central angle subtended by the same arc BA. Also you have a tangent BD here. So measure of the angle ABD plus measure of the angle E equal 180 degree. Here is vice versa. If you have angle of measure, this angle BAD, this angle, equal measure of this angle angle C. What do you deduce? Yes, AD is a tangent which passes through A, B, and C. And AB is a chord into this circle. Now, my lovely student, let us show a model of an exam of the second term. First question is choose the correct answer. Look at this figure. You have a circle M. BM equals 6 centimeter. AB equal 8 centimeter, and the AB ray is a tangent. Then what is the length of MA? What is the length here of MA? Yes, very good. Look at this. MB, this radius, is perpendicular to the tangent AB. So you have here angle of 90 degrees. Very good. By using Pythagoras theorem, this side is 8 and the other side of the right angle is 6. What is the length of the hypotenuse? Yes, AM equal root AM equal root 6 power 2 plus 8 power 2. Very good. Equal what? Equal 10 centimeter. So the answer is 10 centimeter. If two circles M and M are touching externally, the radius length of one of them is 5 centimeter, and the MN, yes, this is a line of centers, equal 9 centimeter. Then the radius length of the other circle equal what? Let us remember the relation between the two circles here are touching externally. So MN equals R1 plus R2. MN here is 9. R1 equal 5 plus what? Plus R2. How can I find R2? Yes, very good. R2 equal 9 minus 5 equal 4 centimeter. So the correct answer is 4 centimeter. Number 3. In the opposite figure, the measure of the arc AC is 50 degree and the measure of the arc AD equal 110 degree. This is a well-known problem. I want to find the measure of the angle E. Very good. Equal what? Equal half times bracket 110 degree minus 50 degree. Equal what? Yes, equal 30. Very good. So the measure of the angle E equal 30 degree. Number 4. A circle can be drawn passing the vertices of rhombus, rectangle, trapezoid, or parallelogram. Remember? Yes. A cyclic quadrilateral of these 4 shapes is very good. The rectangle. Do you remember why? Yes, because two opposite angles are supplementary. Their measure equal 180 degree. So the rectangle is a cyclic quadrilateral here. So the circle can pass through the vertices of the rectangle. Number 5. In the opposite figure, ABCD is a cyclic quadrilateral. Measure of the angle D named by X and B is twice X. What is the value of X? Remember, the sum of measures of opposite angles of cyclic quadrilateral equal 180. So X plus 2X equal 180. So you have 3x equal 180. X equal what? 3x equal 180 degree. So x equal 180 divided 3 equal 60 degree. The last one in the choose. Look at this figure. In the circle M, you have the chord AB is parallel to the chord DC, and the measure of the central angle BMD equal 80 degree. Then measure of the arc AC equal what? Remember that if AB is parallel to DC, AB is parallel to DC, therefore measure of the arc AC equal measure of the arc BD. And what is the measure of the arc BD? Yes, very good. It is 80 degree because this is central angle equal the measure of the arc. So BD equal measure of BD arc equal 80. So measure of the arc AC also equal 80 degree. Second, in the opposite figure, you have an equilateral triangle ABC. AB equal AC equal BC. Drawn inside the circle M. Number 1, I want to find measure of the angle BAC. BAC. And also measure of the angle BMC. I want to write the proof here. Since triangle ABC equal is an equilateral triangle, okay, therefore measure of the angle BAC, measure of the angle BAC equal measure of the angle ABC equal measure of the angle ACB equal 60 degree. Therefore, measure of the angle BAC here equals 60. What is the measure of the angle BMC? Yes, it is twice measure of the angle A. So, measure of the angle BMC equal twice measure of the angle BAC equals 120 degree. Why? Because subtended by the same arc BC. Subtended by the same arc BC. Okay? Subtended by the arc BC. Thank you. The next, in this figure, AD is a diameter in the circle M, AB is a tangent, measure of the angle B equal 50 degree, E is the midpoint of DC, find with proof measure of the angle AME, and to prove that AMEB is a cyclic quadrilateral. First, look at the tangent AB. Tangent AB. This is the tangent of the circle. Okay? At the end point of the diameter AD. So what is the measure of the angle A? Yes, it is 90 degree. Since AB is a tangent and the AD of the circle, since AD is a diameter, AD is a diameter, therefore measure of the angle BAD equal 90 degree. BAD, yes, equals 90 degree. Since ME by 6 CD, since ME line segment, ME line segment by 6 CD, this chord CD line segment, therefore measure of angle MEC equal 90. Look at the quadrilateral AMEB again. AMEB. The sum of measures interior angles of the quadrilateral AMEB equal 360. So measure of the angle AME equal 360. The quadrilateral AMEB equal 360. So measure of the angle AME equal 360 minus bracket 90 plus 50 plus 90, close the bracket, equal 130 degree. So measure of the angle AME equal 130. Okay, measure of the angle AME plus measure of the angle ABE equal what? Equal 130 plus 50, and the two opposite angles. So the quadrilateral AMEB is a cyclic quad, since measure of the angle AME plus measure of the angle B equal 180. So AMEB is a cyclic quad. Question 3. In the opposite figure, measure of the angle ABE equal 100 and the measure of the angle CAD equal 40 degree. Prove that ADC is an isosceles triangle. ADC. Look at this figure ABCD. ABCD. Its vertices lies on the same circle, so this is a cyclic quad. So since ABCD is a cyclic, therefore measure of the angle ABE, measure of the angle ABE, this is an exterior angle, ABE, ABE, yes, ABE equal measure of the angle ABE equals measure of the angle D equals 100 degree. Measure of the angle ABE is an exterior, equal this angle equal 100 degree. Yes. In the triangle ADC, in triangle ADC, I can find measure of the angle ACD, measure of the angle ACD equal 180 degree minus 40 plus 100 minus bracket 40 plus 100 equal 40 degree. Since measure of the angle DAC equal measure of the angle CAD equal 40, measure of the angle ACD equals measure of the angle CAD equal 40 degree. Therefore ADC is an isosceles triangle. The next question. Look at this shape. A, B and AC are two tangent. Measure of the angle D equal 70 degree. Find number 1 measure of the angle ABC and measure of the angle A. Okay. AC is a tangent at of the circle at C. Since AC is a tangent, AC is a tangent, therefore measure of the angle ACB or you can find measure of the angle ABC. Measure of the angle ABC, ABC, yes, ABC. Equal measure of the angle BDC, equals 70 degree. Why? Because the angle of tangency equals the inscribed angle subtended by the same arc, BC. Since AB and AC are two tangent, are two tangents, therefore AB equals AC. Therefore measure of the angle ACB, measure of the angle ACB equal measure of the angle ABC equal 70 degree. Now I can find the measure of the angle B. Therefore, measure of the angle A, measure of the angle A, measure of the angle A equal 180 minus bracket 70 plus 70 equals 40 degree. The next question. In the circle M, MB equals 7 centimeter. Measure of the angle AMB equal 120 degree. You can also note that MA is another radius. Find the length of the arc AB, known that pi equal 22 over 7. In this circle M, I want to find the minor arc, the measure of the minor arc BA equal what? Yes, equal the measure of the central angle M. So, measure of the arc BA equals measure of the angle M equal 120 degree. Length of the arc BA equal what? Length of arc BA equal what? Yes, equal the measure of the arc BA equal what? Equal 120. Over measure of the circle. Measure of the circle. All times what? Yes, all times 2 pi r, the circumference of the circle. 2 pi r equals 120 over 360. 120, this is the measure of the arc, over 360, this is the measure of the circle, times 2 times 22 over 7 times 7 equal 44 over 3 centimeter. 44 over 3 centimeter. The next question. In this shape, measure of the angle BDC equal 90, measure of the angle ACB equal 30, measure of the angle ABC equal 60. Prove that the point A, B, C, and D have one circle passing through them. I can also say ABCD is a cyclic. Yes? Yes, very good. In the triangle ABC, look at the triangle ABC, ABC. In triangle ABC. Now you have angle of 30 and another angle of 60 degree. I can find measure of the angle A. Measure of the angle BAC equals 180 minus bracket 30 plus 60 equals 90 degree. Now look, you have angle A of 90 degree and D 90 degree, and this is a common base BC, and the two angles drawn on the same side of the common base. So what is the name, or what is the type of the shape ABCD? Yes, it is a cyclic quadrilateral. So there are a circle passing through the points A, B, C, and D. How can I write this in the proof? Since measure of the angle BAC equal measure of the angle BDC equal 90 degree, and drawn on the same side, drawn on the same side of BC. So therefore ABCD ABCD is a cyclic quad. Cyclic, CY here, cyclic, yes, quad. And you can say A, B, C, and D have one circle passing through them. Next question. Look at this figure. In the circle M, you have a triangle ABC inscribed on this circle, in which measure of the angle B equal measure of the angle C. D is the midpoint of AB. ME perpendicular to AC. Prove that MD equal ME. Look at this triangle ABC. Now you have a point, angle B equal measure of the angle C. You can deduce that AB, yes, equal AC. Since MD bisect AB, therefore this angle is 90. Angle MEMDA is 90. And also measure of the angle MEA is 90. So, yes, MD will equal ME. How can I write this in the proof? Since, measure of the angle C equal measure of the angle B, therefore AB equal AC. Yes, this is the triangle ABC. And I name this with 1. Since MD passing through the center, passing through M, what is this? This is the center of the circle, passing through M. Since MD bisects AB, therefore MD line segment is perpendicular to the line segment AB. Since ME line segment is perpendicular to AC, I will name these two with an equation 2. From 1 and 2, what do you deduce? Yes, I deduce that MD from 1 and 2. Therefore, MD equals ME. As you look here, yes. Thank you. The last question. In this figure, AB is a diameter. Measure of the angle C equal 50 degree. Find with proof measure of the angle CAE. CAE. Look at this figure. AB is a diameter in the circle. Yes. And this angle AEB drawn in a semicircle, you can deduce that is, yes, it is a right angle. So measure of the angle AEB equal 90. Describe the angle drawn in a semicircle. And since measure of the angle CEA also equal 90, because two adjacent supplementary angle. In this triangle, now you have 50 as the measure of the angle C, 50. And here, this angle is 90. Yes, you can find the third angle in the triangle ACE. It will be 40. How can I write the proof? Since AB is a diameter, therefore, measure of the angle AEB equal 90 degree. Measure of the angle AEB equals 90 degree. Why? Because it is an inscribed angle drawn in a semicircle, as we said before. Measure of the angle AEC, measure of the angle AEC equal 180 minus 90 degree. Minus 90 degree equal what? Equal 90 degree. Why? Because two adjacent supplementary angles. So in triangle ACE, measure of the third angle in the triangle ACE, measure of the angle CAE equals 180 minus 90 plus 50 equals 40 degree. And this is the end of the final revision in the third prep. Thank you, and we wish you secondary school next year. Thank you and good luck.